Today we're going to be talking about how to use inequalities to describe a region in three-dimensional coordinate space. And in this particular problem, we've been asked to use inequalities to describe the region, which consists of all the points between, but not on, the spheres of radius lowercase r and uppercase r, which are both centered at the origin, where lowercase r is less than uppercase r. Now, that sounds really confusing and silly, but it's actually not that bad. So what we first need to realize is that we have two spheres, one that's nested inside the other. And the smaller one has a radius of r that comes out from the origin. So for example, if I can just say that this orange sphere on the inside here is centered at the origin, and that its radius here, if I draw a line from the origin to the edge of this smaller sphere, the radius is lowercase r. At the same time, I have this larger sphere, which is lying on the outside of this smaller sphere, also centered at the origin, whose radius is uppercase r. So if I draw a line from the origin to the edge of this larger sphere here, I can call the radius uppercase r. We know that uppercase r is greater than lowercase r, which tells us that the sphere with radius uppercase r is larger or outside of the sphere with radius lowercase r. So that's how we know how to draw that picture. They're both centered at the origin, both spheres, uppercase r greater than lowercase r. So now, how do we use inequalities to describe the region between them? What we're looking for is the region that's inside the larger sphere, but outside the smaller sphere. And it doesn't include the set of points on either sphere, just the points in between them. So really what we're looking for here is this space in here, all this space in here that is inside the larger sphere, but outside the smaller sphere. So all this area here, that's the region that we're looking to describe. Well, let's talk about the equation of a sphere. We know that the equation of a sphere is the following. It's x minus h squared plus y minus k squared plus z minus l squared is equal to the radius squared. In our case, we know that the center of both of these spheres is the origin. And remember that in this formula for the equation of a sphere, the center is represented by the coordinate point HKL. Well, because both of our centers are at 0, 0, 0, what we can say is that we're going to get here for both of them x minus 0 squared, y minus 0 squared, and z minus 0 squared, which is just going to give us x squared plus y squared plus z squared when we simplify the left-hand side. That's going to be equal to r squared. Now this is exactly the equation of the smaller sphere. The equation of the larger sphere would of course be x squared plus y squared plus z squared is equal to uppercase r squared. So we're looking for the set of points that lies between these two. Well, this second equation here, x squared plus y squared plus z squared equals uppercase r squared. This represents exactly the set of points that lie on this larger green sphere. So this set of points here, everything on this sphere. In other words, it's like a hollow shell. It's not a solid ball. It's a hollow shell of a sphere. And that equation represents all the points that lie along the outside of this sphere here, all these points. So we don't want to include those points. We only want to include the points that are inside this. So what we're really looking for is the set of points x squared plus y squared plus z squared, where that value is less than r squared. This inequality here models all of the points in three-dimensional space that are inside this hollow shell of this outer sphere here. So these are all the points, basically the solid ball that lies inside this larger sphere, but doesn't include the shell of this larger sphere. And we don't want to include the shell because it says consisting of all the points between, but not on the spheres. So we want it to be less than capital R squared. If we wanted to include those points, if it didn't have this but not on clause here, then we would say less than or equal to here for this inequality. But because we don't want those points, we just say less than. So this includes all the points inside this larger sphere from the shell of the larger sphere all the way down into the origin. But we don't want that. We want the points that are outside the smaller sphere, but inside the larger sphere. So all we have to do to limit that region is just say that this value also has to be greater than lowercase r squared. And again, if we wanted the points that were on the shell of that inner sphere, we would say greater than or equal to here instead of just greater than r squared. But this is our final answer for our inequality. This is the inequality that describes the region that consists of all of the points that are between these two spheres, but doesn't include the points that lie on the shell of the outer sphere or on the shell of the inner sphere.